Hello and welcome to the last lesson of Module 11. We're going to solve by square rooting today. So we can find the roots of a quadratic equation by taking the square root of both sides. So just a real quick review. How many solutions can a quadratic function have? It could have 0, 1, or 2. And you can see all those examples there on a graph. How many ways can we find solutions to a quadratic equation? How many different ways are we allowed to? How many methods? Well, we've done graphing. We're going to do square rooting today. There's also completing the square, factoring, and quadratic formula. Those are coming in the next few weeks. So at the end of this lesson, we'll be through 2 of those methods of the 5. So solve by square rooting. Let's take a look at something here. Let's solve this quadratic equation. Let's get x by itself. So what I'm going to do is I'm going to add 27 to both sides. When I do that, I get 5x squared plus 18x equals 74. To get rid of that squared exponent there, I need to take the square root of both sides. Well, that becomes a problem. This 18x gets in the way. I can't take the square root of this yet. If I bring the 18x over to the other side, I can't take the square root over there either. This I can't do that here. So what do I have to do? Well, that problem we can't solve yet. We don't have the method to solve that one yet. But what you need to understand is that we can solve an equation using square roots only if the b value is 0. Now that means that there's no linear term. So this term in the middle, the one that has just an x, you can't have that term. If you do, you cannot do square roots here. So here's an example of one that you could do square roots. This only has an a term and actually a c term. The c term is the 16. If I brought it over, it would be negative 16. Okay. This one has an a term and a c term. There's no x value. This one, though, has a 10x. I cannot do square roots with this problem. I would have to do some other method. So example 1, let's find the roots of the equation. When I say find the roots, I'm talking about the solutions. I'm talking about the x-intercepts. These all mean the same thing. So what I'm going to do is I'm going to get x squared by itself. So I need to move the 8 and the 2. So I'm going to move the 8 first by adding it to both sides. Okay, so I get 2x squared equals 8. Then I want to get rid of the 2, the coefficient of 2. So I'm going to divide by 2. That gives me x squared equals 4. Now, how do I get rid of the exponent? Now I take the square root. The square root of x squared is just x. Square root of 4 is 2. But that's one solution. Is that okay? I don't know. Let's take a look. Let's go back to what we did last lesson. We graphed. I'm going to do this very quickly because we got done with this already. Find the middle. So the b term is 0. That's nice. 0 divided by anything is 0. It's going to put the middle right down the y-axis like that. 0 goes in the middle of the table. There's the rest of the x values, 2 smaller, 2 bigger. Plug those in, and those are the numbers you get. Plot them, and you see it crosses the x-axis twice, at -2 and at +2. Why did I only get 1? Well, because when you introduce a square root, what I mean by that is, back at the very beginning, the 2x squared minus 8 equals 0, there was no square root in there. Okay, we introduced the square root by solving it in this step here. We did x squared equals 4, and we took the square root of both sides. Whenever you introduce the square root, you always have the positive and the negative roots. So we can say plus or minus 2 when we take the square root of 4. And it should make sense because when I'm taking the square root of 4, I'm looking for 2 numbers that multiply by themselves to give you 4. Well, positive 2 times positive 2 gives me 4. But doesn't negative 2 times negative 2 also give me 4? It does. Therefore, we have to include both when we take the square root of a positive number. Okay, that's one thing you do have to pay attention to with this unit. All right, so let's solve this one. I'm going to get rid of the 15 and the 2. So I'm going to subtract 15. 2x squared equals -10. Divide by 2. X squared equals -5. Now take the square root of both sides. What's the square root of -5? Can you take the square root of a negative number? No, you cannot. This one has no solution, or no real solution. Okay, because you can't take the square root of a negative number. Now, if I were to graph this, this would open up, and it would never cross the x-axis. That's what this means. There's no solution. It means it never crosses the x-axis. All right, connection to what we've already done. One more example here. Let's solve this one. We're going to add 5 and then divide by 4. 100 divided by 4 is 25. Take the square root of both sides. We just introduced the square root, so we got to have 5 and -5 as my solutions. There's an easier way to write that. And once you get used to writing it this way, because you're seeing it this way a lot, it's plus or minus 5. Okay. Again, we call these answers at the end the roots of the equation because we're taking the square root. These are the solutions. They're the same thing. Okay. And so that concludes lesson 3 of module 11. And that concludes our lessons for this week.